Buddy, you like school? You like school? Yeah? You want vacation? Yeah? You want to go to eat a hamburger? Do you like math? Do you like math? No? You don't like math? Nothing? How about geometry, if I be specific? Geometry? Yeah?
Morning, y'all. I hope you're having a good day. Today is our last lesson of the year. Did you hear that? The last lesson of the year. I know it's a little bit sad because it will also be the last lesson that I will be giving to you because after math analysis, there's no other class that you will be taking with me. However, I'm hoping that if things go back to normal, that you come back as TAs or you come back and come to tutoring or Saturday school whenever you need help. So I'm still going to be around, and don't forget to continue to be involved with the Leos Club and with school. And when it's time for letters of recommendation, come over and visit me. You see? You hear? Alrighty, here we go. So today's lesson is on the law of sines and the law of cosines. I am first going to go over the two lessons that you need to learn or understand. I'm going to give you one quick example here, and then I'm going to go do some of your problems from your own packet, okay? So the law of sines states that little a is over sine of big A is equal to little b sine of big B. Now I realize that this cannot be possible because you cannot have two equal signs in an equation, right? However, it's only two of these, so it's either those two, or those two, depending on what values you have, right? Now I will say one other thing. It doesn't have to be in this form. It could be flipped around. It could be the sine of A over little a is equal to the sine of B over little b. Please remember that capital A's are angles and little a's are lowercase letters, okay? Point in case, let me go do an example over here. And what I'm reminding you is that the law of sines works for angle, angle, side, angle, and side, side, angle, otherwise known as angle, side, side, the nasty one if you remember, otherwise known as HL, hypotenuse laid, from geometry, long time ago. Alrighty, so supposing I was to give you this question here, and I wanted to know the value of x. Well, then you use the law of sines. And it's easy to see because you can set up an x here and like this and like that. So you can say x is to the sine of 60, opposite, as 5 is to the sine of 20. And if you saw sauce, cross multiply, you'll be able to solve for x. But in my case, I'm just going to multiply those two and leave the x by itself. So x is equal to 5, the sine of 60 over the sine of 20. And all you got to do is multiply 5 sine of 60. Remember, you got to be in degree mode on your calculator and divide it by the sine of 20. And you'll get your value of x. Obviously, it's going to be a decimal, okay? What if, however, instead of finding that, you wanted to go and find y over here? Now, let's say this was 8, okay? After we did all the math, supposing it was 8, right? What if you wanted to go out and find y? Well, you can use the law of sines again, but this time you would say, you'd have to find what this angle is. And of course, it's easy to find the angle, right? Because 60 plus 20 is 80. So by triangle sum, this is 100 up here. So you could use the law of sines again. Y is to the sine of 100 as 5 is to the sine of 20, and you would finish it up, right? What you're going to notice here is that there is no right angle, huh? So all those years that we've been telling you that trigonometry only works with right triangles, well, we were sort of lying. Sorry. But this part of trigonometry, the law of sines and the law of cosines, the triangles could be oblique, which means they don't have to be right triangles anymore. Okay, so let me go back over here and go over the law of cosines. So there's two assignments for you to work on the law of sines first, and then you're going to come back to the law of cosines. Same triangle, but now we can work with side, 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 or side, angle, side. Okay, the law of cosines states this, that when you have the lowercase letters a, b, and c, a squared is equal to b squared plus c squared minus 2bc cosine of a. What you have to notice is that whatever lowercase letter you started with A, you finish with A. This could be B squared, so this would be a big B. This could be C squared, so this could be a big C. And of course, you're going to notice that these two letters also repeat here, okay? This is a law of cosines when you're missing a piece. So I can go back over here and use the law of cosines to find out what y is. You would say y squared is equal to the other two guys squared, 5 squared plus 8 squared minus 2, these two numbers, times 5 times 8, cosine of whatever you started with, opposite, which is 100. You can then go straight into the calculator and say 5 squared plus 8 squared minus 2 times 5 times 8 cosine 100 in one shot. The calculator will do it for you. It will then give you a y squared is equal to some number, to which of course you know that all you have to do is hit the square root button and you'll know the value of y. This is the law of cosines and the law of sines, which we will be using. First, we will practice with regular triangles like this, and then comes the harder part. All the real world problems, word problems that are in the real world, the applications that engineers use the law of sines and law of cosines, because in real life, not everything is perpendicular with right triangles. That's why the law of sines and law of cosines are so important. So, my last lesson. Now let's go practice. Miss you. Bye. So as you saw in my introduction, even my dog at home has developed a love for mathematics, especially in the area of geometry, which is what we're going to be learning here today. This is a recap of the law of sines. It is used to solve oblique triangles. In other words, you don't need a right triangle anymore, okay? You could have any triangle work out this way. And you must also need to know at least one of the sides. In other words, this guy has a side, this guy has a side, and this guy has two sides. So you have to have at least one of the sides and then the angle or the angles, right? Now this particular one was HL, side-side angle or angle side-side from geometry, if you remember a long time ago. That one's going to have some special features which are called the ambiguous case, where sometimes you have no triangle, sometimes you'll only have one triangle, and sometimes you'll have two distinct triangles. But in the interest of time this year, sorry to tell you that we're not going to go in depth into this particular part yet. And so we're just going to focus on the oblique triangles. Once again, I'll also remind you that you don't need all three of these, just two of them. Those two, or those two, depending on which sides you're given. Because obviously you cannot have two equal signs in an equation, right? One other thing that I didn't give you in my first lesson, and that is that now we can find the area of any oblique triangle. And this is what people use to find area of land or roofs. The roofers do this all the time at Home Depot, for example. They'll take a picture of your house from above, from the satellite that's flying, or Google Earth, and they'll develop triangles out of your roof because they're all not right triangles, and then they'll use this formula. You're only going to be doing this on the second part of the assignment, not the first part. But the area of an oblique triangle, not a right triangle, is 1/2 BC sine of A. B and C, of course, are the lowercase letters. B and C are lowercase letters in the sine of A. Okay, this is how we find the area of an oblique triangle. So we are going to start on this homework assignment here. And what we're going to focus on this year is from 10 to 20, the multiple choice questions that I will be placing on your Friday quiz, and also on your test that you're going to be taking next week, and on your final the week after that. We will not be doing 1 through 9 because they're a little bit more time consuming, so we're just going to focus on these questions here. And even though there are 4 of them, A, B, C, D, I'm only going to require that you do 2 of these. But some of you are going to develop a love for them, or you're going to be going to tutorials and you're going to see, hey, I like this kind of stuff. In which case, you can always do C and D from 10 to 20 and get some extra credit, okay? Alrighty here, let's get started then. That's the packet. Let me start with number 10. Once again, you are not doing 1 through 10. And number 10 looks like this. It says for you to use this triangle and use the law of sines to come up with one of the answers that they've given you. So you can say little a is to the sine of a as little c is to the sine of c. Or little b is equal to the sine of b. So you're going to start with any two that you like, and then you're going to sauce and see if that's one of the answers that you find there. So let's see. I'm going to start with little a is to sine of a. That would be these guys here. And little b is to the sine of b. That would be those guys there. Okay? You can see it's the cross, so it's easy to tell it's the law of sines. And now I'm going to solve for one of the variables that it says to solve for a, right? It says, what does a equal? Okay, well, if I cross multiply just like I did up here in the diagram, you're going to see that you're going to get a sine of b is equal to b sine of a. But rather than for you to cross multiply, since I'm solving for a, leave the a alone and then just take this guy and put it up here because you're cross multiplying anyway. And when you do that in one shot, you get this, and then you're going to go ahead and take a look at the question, and you're going to see it's letter D. Okay, so it was just asking to see if you could understand the law of sines. Alrighty, let's move on to number 11, where we actually have to solve one of these pieces. And here is number 11. They want you to find PQ. So I have set PQ equal to x, and all I got to do is say x is to the sine of 60 as 5 is to the sine of 70. And there we are. When you cross multiply again, I'm solving for x, so all I'm going to do is put the sine of 60 over here, and x is by itself. You don't really need to sauce. So when you do that, of course, you're going to get this, and then you're going to go to your handy-dandy calculator, to which you're going to plug in 5 sine 60 divided by sine of 70. Of course, in degree mode, and then you're going to get your answer, right? That's it. Okay. Number 12, it says for you to find PQ again. So I'm going to call it X. It's easier for me to write X than it is for me to write PQ. But they also give you values. It says that the sine of R is 1/4 and the sine of Q is 2/3. Okay, fine. So that means they want me to use Q and R, right? So R and Q. So let me go set up my little X here. That helps me. There is R, and here is Q. There's my little crisscross, which means law of sines. Okay, let me go use this law of sines. That means that X is to the sine of R as 5 is to the sine of Q. And that's exactly what I have written right here. X is to the sine of R as 5 is to the sine of Q. But they had already told me that the sine of Q was 1/4. So I'm going to plug in here 1/4. And they told me that the sine of Q was 2/3. So let me go plug in those two values, and you get this. When you sauce, you get 2/3 of x is equal to 5/4. Or once again, since you're solving for x, don't sauce. Just take the 1/4 over here and put 1/4 there, and you're done. So now 5 times 1/4 is 5/4. And 5/4 divided by 2/3 is 5/8. Or go ahead and sauce here and then multiply by the reciprocal, right? 3/2, and you'll end up with 15/8 anyway. Okay, that's number 12. Going on to number 13, they're going to give you this particular triangle, and they're going to be asking you the ratio of B over C. Basically, they're telling you to use B and C because they want the ratio of B over C. Okay, that means that B is to 30, the sine of 30, as C is to the sine of 45. Okay, let me go ahead and do that. So B is to the sine of 30 as C is to the sine of 45. And there's your law of sines right there. So now, once again, I'm going to sauce. When you do that, you get B sine 45 is equal to C sine of 30. And there it is. But they wanted the ratio of B over C. So let me make sure that I divide by C, cancel that away. So I end up with B over C. But then again, there is the sine of 45 that's in my way. So let me divide by the sine of 45 and cancel that. So now, B over C, which is the ratio they wanted, is the sine of 30 over the sine of 45. Well, let's go find those values. The sine of 30, if you look at your chart or the triangle, is 1/2. And the sine of 45 is 1 over radical 2, which is radical 2 over 2. The 2's cancel, and so therefore, when you have 1 over radical 2, you know that it ends up with radical 2 over 2. That is Lucky Churching. And I will only do one more because by now you probably have noticed that these are very repetitious. Yeah, once you know how to do one, you basically know the other. So they're asking you for the largest angle. Well, the largest angle is the one that's up there, so the obtuse one. So let me set up my crisscross. There it is. It's the law of sines. So 16 is to the sine of 44 as 23 is to the sine of x. There we are. Except you're going to notice that this time I flipped it over, right? I didn't put 23 is to the sine of x as 16 is to the sine of 44. I could have, but because I'm solving for x, this time I flipped it over. I told you earlier it doesn't really matter so long as you have a true proportion, right? Okay, so since I'm solving for x, let me go ahead and solve for x. I'm going to crisscross or cross multiply, but since I'm solving for x, I'm just going to move the 23 over to the other side and cancel it here because that's what cross multiplication would give me anyway. So now you have the sine of x is equal to all of this. Okay, so this time I will use the calculator and press 23 sine of 44, close the parentheses, divided by 16, enter. So what I have is 0.9986. You will remember that whenever we are looking for an angle, we always press second function. So second function sine 0.9986, enter, and you get 86.9. In other words, this is 87 degrees. Voila! That's the law of sines. And what is the key word for this week? Because it'll be on your quiz someday in the future. The key word is goodbye, goodbye, goodbye. But not for long. We'll be seeing each other soon. Let me continue on with the law of cosines now. Let me get all of this paperwork out of here. That's the law of sines. We're done with that one. And of course, I'm going to say the same thing for the law of cosines. Do not do the first 10, the first 9. Start with 10 and go all the way to number 19. Okay, the law of cosines starts like the Pythagorean theorem, and then minus 2 of those two guys there, and then you end up with the same letters. So if you start with A, you finish with capital A. And this guy here now is for side, 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 or side angle, side. That's how you will know right away. I'm going to give you another formula here. It's called Heron's formula, and this is how you find the area of triangles by side, side, side. Once again, you don't need any right angles, and we will practice this on the next packet when we get to the word problems. But for now, download those 2 pages with the notes. I've already uploaded them for you. And this is for side, side, side. The area is equal to the square root of s minus a, s minus b, and s minus c. Obviously, a, b, and c are the lengths of the 3 sides because you had side, side, side. But the question is, what is this s business? Well, S is like an average, except it's not really an average because you're dividing by 2 instead of 3. But to find the value of S, Heron found out that if you add A, B, and C and divide it by 2, that's your S value. And then you put it right there. You take away the first value of the side of the triangle, the second and the third. You hit the square root button, and voila, comes out the area. As I was saying, once you use Heron's formula, you don't need a right angle anywhere in the triangle. Okay? All right, let's put that aside and go to the law of cosines. I'll say it again. 1 through 9, you don't have to do. We're only doing the multiple choice questions, and we're only doing A and B. C and D, extra credit.
which you could probably use, right? Right about this time. Okay, so let me go ahead and get my questions. Again, I'm going to do about 5 examples for you. That should do it. Let's begin with number 10. Here is number 10. It is asking for the side little a over here. So to find it, you're going to use the Pythagorean theorem. That's the way it starts anyway. And say a squared is equal to 8 squared plus 10 squared minus 2, 8, 10 cosine of a. And so remember that whatever little letter you start with, you got to finish with a big capital letter. All right, so this is the way you write it. You start with little a squared is equal to 8 squared plus 10 squared. And then minus, always minus 2, those two numbers again, 8 and 10, and then cosine of a. And then you just go find it, and that is the law of cosines. You don't have to solve it. I just want to see if you know what it looked like, okay? That's number 10. So let's go try another one of these. Number 11 with variables. Okay, so number 11 says for you to go find, using the little a again, number 11 states, find PQ. Oops, that was for the law of sines. Number 11 of law of cosines says to find out what a squared is. In other words, they want you to find that guy right there, okay? So let's go find out what a squared is. So if I'm going to start out with little a, I better finish up with big A, cosine of 60. Okay, so little a squared is equal to little b squared plus little c squared minus always 2 bc cosine of 60. So now we're going to plug in the value of cosine of 60, which is 1/2. The 2's cancel out, and you end up with b squared plus c squared minus 2 minus the bc because the 2's canceled away. And that's number 11. Okay, as you can see, this is not really that difficult. They'll get a little bit more challenging when we do the word problems, but we hope you come and visit Oscar at Tutorials and he'll make it all nice and clear for you. All right, what does number 12 say? It wants cosine of the angle QPR. In other words, they're looking for this angle P right here. All righty, so if I'm going to end here, then I better start there. All right, so you're going to write little 3 squared is equal to little 4 squared, little 2 squared, minus 2, and then use those 2 and 4 again, or 4 and 2. There's your 4 and your 2. This 2 is always there, cosine of P. Okay, after you do that, that is 9, that's 16, that's 4. 2 times 2 times 4 is 16 cosine of P. Now, get this 20 and subtract it. When you subtract 20 to the other side and positive 9, you get negative 11. When you divide by that negative 16 right there, divide by negative 16, divide by negative 16, you get the cosine of P to be 11 over 16. There is number 12. Okay, so let's get to some real math here where you actually have to solve for sides, right? All righty. Once again, this is the law of cosines, and they're looking for this side over here, x. So this time you're going to write little x squared, 18 squared is equal to 18 squared and 28 squared. So there's your setup. Little x squared is equal to 18 squared plus 28 squared minus 2, 1828 cosine of 41. Believe it or not, if you just plug all of this the exact way that you see it on the calculator, you'll get it. Except that this is x squared. So what must you do at the end? That's right. In other words, you'll get x squared is equal to some number once you plug in all of that into the calculator, and then you hit the square root button and you will get your x value. It will probably be some decimal. Don't worry about it. It's okay. Okay. Jumping over to number 16, it's looking for the largest angle. Well, how do you know which one is the largest angle? Well, that's not too difficult because if this is 8, that's the biggest number. That means that they're looking for Q. So those are the two that I will circle here so I can go figure out the largest number. And then you just do the math. Well, I'm going to start with little 8 squared is equal to little 7 squared plus little 4 squared. That sort of looks like the Pythagorean theorem, right? Minus always 2,
4, 7 cosine of whatever I'm looking for, which is big Q. Okay? Once again, you are going to get their values. This is 64, this is 49, this is 16, 28 times 2, this is 56, cosine of Q. So now, to finish this, you're just going to subtract those two numbers, 49 and 56 from 64. And that's going to give me what? 5965. So when you bring this over, it's going to end up being -1 is equal to -56 cosine of Q. Okay. And let's see, I'm going to then divide by -56. And so the cosine of Q is equal to 1 over 56. To which you will hit the second function button, which will give you the little -1, and you'll find out what Q is. Okay? One last one for you, only because this one was a little bit of trickery the way they stated it, okay? This is number 17. It says the base of an isosceles triangle. So here's my isosceles triangle, two equal sides. Is half as long as the equal sides. So the base over here is half as long as that. In other words, the two equal sides are twice as big. So I made this x, I made those 2x and 2x. And they are looking for the answer to the smallest angle. Well, obviously, these are the bigger angles because that's 2x, and this is the smallest angle, P. So all you have to do is start with little x is to cosine of P is equal to 2x squared plus 2x squared minus 2 times 2x cosine of P. All right, so I did it all right there. When you square everything, this gives me x squared, that gives me 4x squared minus 2, and this is 8x squared. Then you are going to move all of these x squares over to the other side. Well, 8x squared take away from 1x squared is -7x squared. And when you divide both sides by -8x squared, -8x squared, and cancel everything, you're going to end up with a cosine of P is equal to 7 over 8. Okay? That's the lesson. What was the key word? Goodbye. That's right. Don't forget, it'll be somewhere down the road. Have yourselves a beautiful day. Remember, I miss you, I love you, and I hope to see you sometime real soon, okay? Take care. Stay safe. Bye-bye.